stub or data dump. 19,820 psi burst pressures combined at a specific end if you do the combination I'm going to describe. You start off with wrought steel pipe or wrought iron or black pipe. You use a Schedule 80 extra strong pipe that is labeled 3/4 inch. The outer diameter is 1.05 inch and the inner diameter is actually 0.742 inches inner diameter. Now that will interference fit, unless you sand off the inside of the next pipe, into a 1 inch Schedule 40 standard pipe that's 1 inch labeled. The inner diameter of it is 1.049. So it's a little smaller than the outer diameter of the next one down. That's so you can literally heat up one and cool the other and put them together and they'll automatically lock, or just remove the seam, which almost always is in both of them, and that would, in the process of cleaning it up, you're going to end up changing the diameter just enough to do this. This also allows you to simply thread into the larger one and then thread the outside of the smaller one and then screw them together, which is really where this came from. A lot of the fittings for 3/4 inch pipe are just the 1 inch standard Schedule 40 pipes that are turned into the fittings, or at least that's what you might find on some websites. But the PSI bursting pressure, the actual incidental bursting pressure, much, much higher number than the working pressure, which can cause it to fatigue or fail. The burst pressure is for the Schedule 80 pipe that's 3/4 inch labeled, but it's really 1 inch outer diameter and 0.74 inch inner diameter approximately, is 11,730 psi. The outer metal tubing that can go over it, or pipe, is around 8,900 psi rating. Combining them together, you end up with 19,820 psi. Now, coincidental, that diameter at being basically 74 caliber is a little bit too big for the ideal or stated number for 12 gauge, which is really just 73 caliber. It's actually 72.9, but it doesn't matter. Let's call it 73. This is 74. It's the wrong diameter. But then again, most shotgun barrels, 12 gauges, are actually 74 caliber barrels. They don't bother making them to the correct standard because they don't have to. It's a shotgun. And these burst pressure combined levels at 19,820, what is the proof load you have to have for burst pressure for a 12 gauge barrel? 19,800 psi. Literally 20 psi lower than the max burst pressure if you put together a standard slam fire shotgun. If you made them do a very, very tight fit, both metal tubes would be a combined PSI rating that would easily be acceptable. So that you could just build up the thing that way, or just rely on them being combined together at the only time the gun can be fired. SAAMI shotgun max limits for the individual barrel are, for the cartridges, 11,500 psi or 14,000 psi. That's for the larger cartridges like magnums. And again, the PSI burst pressure for a Schedule 80 pipe, not the standard Schedule 40 that the shell will just drop into and be wiggling a little bit, but still be in there, it's 11,730. All by itself, a Schedule 80 pipe is already at the rating that you need for a barrel. It's up near the limit. And because, again, normally it's not going through a constriction like 73 caliber, it doesn't have a pressure buildup that way. At 74, this would almost entirely match that requirement. Now, I decided to look up what the test barrels are, because test barrels for doing ammunition testing and doing it to SAAMI standards require very specific and very oddly familiar numbers here that I'm going to bring up. So let's start off with the length. How long of a barrel do you have to have as a test barrel? It's not required, but it's the one SAAMI recognizes. Okay. The test barrel is supposed to be 30 inches, or 762 millimeters, or 76 centimeters, or whatever. And that's a SAAMI test barrel from the muzzle backwards. It also includes restrictions and constrictions for chokes. But let's talk about the rest of it. They want it to be a 72.5 caliber, 0.725 inch inner diameter metal tube. There aren't any. I've looked up all the pipe types. That's not a common thing. But that's if it's smooth bore. What about if it's rifled 1 in 35 inches, like is the suggestion? For rifled barrel, it needs to be, and here's the odd number, 0.719 inches inner diameter and then it's rifled out to 0.727, 8 grooves. Okay, steel tubing, 0.732 inner diameter, 1 inch almost exactly on the outer diameter, is about as close as you're going to get to being the water pipe diameters, and that's 73 caliber almost. Then there's one that's 0.875 outer diameter. It's a bit skinny, a bit thin, not a good PSI rating, but it is aircraft grade, so it probably has a higher PSI rating, if they even measure it. And it's 0.731, just a bit over 73 caliber. Both of these would work, and you can obviously do some sleeving of one over the other and maybe compensate for it. Then you get the 0.742 inner diameter, 1.050 outer diameter Schedule 80 pipe that I mentioned. Which again, if you use it larger than 73 caliber, it won't have the ability to go up the PSI rating, but it does perform well. You still have to make a chamber for these things because you're not doing something that's the bore of the shell going out. If you use Schedule 40, even though it's weaker, there's literally nothing containing the pressure except the propulsion inside of the chamber being sealed by the back of the shell. If you do a good job of fitting the rim and the base of it into a Schedule 40 pipe, or just wrap it with tape, that's the only thing providing propulsion, and the barrel almost takes no stress at all, no matter what you throw down it. But here's the funny thing. There's a 1.125 inch outer diameter steel tubing used for aircraft frames and roll cages that has an inner diameter of 0.719 inches exactly. That's what it states on every site I've looked at. I thought that was kind of familiar, and then again I read the land diameter for the inside bore of a test barrel that would be SAAMI certified as 0.719 inches, exactly the same number. So you'd buy this and rifle it, 8 grooves, 8 lands, at 1 and 35, out to 0.727. That's it. That's all you got to do. So that's a really small amount. 1/100th of an inch is, first of all, just cleaning up the thing to where it's decent inside, you can end up changing its bore diameter anyway. But doing the grooves, you can electrochemically etch that. So what are the rest of the requirements for a test barrel? Well, first of all, again, there's an off-the-shelf item to make one for rifled barrel. For the non-rifled barrel, for smoothbore, it needs to be 0.725 inches. And again, there isn't one. So you'd have to start off with the same thing, and, well, you'd just sand it until it was the right diameter instead of rifling it. Now, coincidentally, what's the choke test? And do you have to make barrels that have integral chokes? Okay. 3.4 inches of choke has to be existing in your test barrel or as a add-on choke. The test constrictions for them, for lead shot versus rifled slugs versus non-lead shot. For rifled slug, max choke, it's 0.718 inches. Yeah, it's almost the same thing as the normal bore diameter, and it's optional. So the barrel, obviously starting off being rifled, that's the maximum constriction right at the mouth. But you can just omit it because it's already 0.719. Again, that's a piece of tubing off the shelf. You buy it from some company. If you're doing a non-lead shot and want to have the maximum constriction allowed, it's 0.72, which means you just sand it out, and that's for smoothbore. And then you re-ream it from the chamber in, and then create put 3.4 inches from the end of your barrel. This is the same barrel blank. You'd stop reaming it that way and then put in a chamfer on it, and that would be your choke. You could even angle it from that point into a funnel. Again, this would be industry standard non-lead shot choke, a steel barrel that you would maybe buy for at 30 inches, or if you wanted to make a test barrel, a lot cheaper than the $1,000 test barrels or something like that. I looked at the test barrels. I'm not even going to quote the prices. They're obscene. What about lead shot constriction? Again, this is essentially you putting a choke on it. You could just, put the threading in it and make screw-in chokes for the same thing. Yes, they allow you to use a screw-in choke on all of these, except for, of course, the fully rifled barrel. They don't want you to use a choke at all. Obviously, they're indicating 0.718 versus 0.719. It's about the same standard, so just literally you start off with a blank and make a rifled barrel, and then the non-lead shot, if you're going to make a steel shot barrel, you just kind of sand it a little more. Again, it's within the plus or minuses, so you can use the same blank. Again, we can use the same thing. One's rifled and one's not. Smoothbore, but that's for non-lead shot. Steel and tungsten, hard stuff. Lead shot, for a choke test, they want you to use it at 0.694. That implies strongly you'd use a screw and choke. But yes, well, yeah, that's what you'd do. You'd have a screw and choke for that. So what you do is you'd have the bare barrels and then have one that would be for testing chokes. If you're going to do lead shot checks, that's the choke they want you to use as your baseline, so you would just include a screw and choke and make it perfect. Okay, well, let's talk about the barrel's parameters. Okay, the rim diameter, we're starting with the rim diameter. This is not how you drill it out, obviously. It's 0.887 inches, which is about the same. This is the strict standard. Well, there's some pluses and minuses. Okay, what about the base diameter for the cartridge? Now, this is one where we find out the real secret. If you're doing 2 3/4 versus 3 inch versus 3.5 inch, the ream that's used is simply a tapered ream because the base diameter is 0.81 inches for the shorter shells, and it's 0.8111 inches. It means that the ream for forming the chamber is simply continually tapered. The deeper you go in to ream it out, the more it makes the base looser for it. That just means you're allowed to get away with it. It's the same chambering. It's not really any different. And that's, again, for the 11,500 PSI max versus the 15,700 PSI max versus 14,000 PSI max ranges, depending on the length of the shell and whether or not you're shooting magnum or not. And the mouth of the case is 0.798 inches at 2 3/4 approximately depth, and also for the 3 inch and such. It's the end of the ream that goes in, and the rest of it is the forcing cone that goes on for 0.8 inches or 0.4 inches, depending on power level. And again, this goes from 0.798 or about 0.8 inches down to 0.72 inches approximately again. So you're reaming this, and if you're not aware of that, that's a 13/16 inch drill bit and then a ream. You drill it progressively to get to that size, and you just keep doing it to the depth you need. And also remember, if you're going to make a gun that does only 2 3/4 and you're never going to load anything else in it, you can drill it to that depth and have it have a very abrupt end, and that may make it better. You may not want to put a forcing cone on it. You might just want to put a really harsh angle on it, like a 45-degree angle at the edges, just to make sure it doesn't shred anything. So, what does this come down to? Well, first of all, the default behavior for a rifled barrel that's used for testing and the starting point for making the diameters for choke, for non-lead, and all the other things, start off with a barrel diameter that would be considered extremely tight, old school style. Or you can go to 0.74 or 0.73 with having almost a 1 inch outer diameter for all of them and still have the same thing. And again, by combining these layers with other metal tubing, you do have something that does meet the criteria for being safe and effective, even up to proof loads. Testing pressure within these chambers, you'd have the choice of a $2,500 piezo transducer that has to require you to drill things, or a $5 glue-on strain gauge, which, yeah. The information grabbing on it, you can use an audio recorder for it, or a storage scope. Anyway, drawings of the test barrels are presented in section 3 of a file that's PDF from SAAMI below, and also you can just get 12-gauge barrels like this that are cheap throwaway ones for $30 to $50 on eBay. They're always out there. They're always that cheap. Starting point. Just get the buy it now option. So it seems like the SAAMI test criteria for building all of this is pretty easy. And all the links below in the description will help you. Even if you want to DIY it, you can get away with it and do it safely. Thanks for watching. Have a good day. Good luck.